So welcome everyone in the lecture 6. So today we are going to talk about the AI models for infrastructure monitoring one. So you could see clearly that we have tried to divide into three sections, which is part 1, part 2 and part 3. So today in the day 4 we will talk about the part 1 and part 2, and following that tomorrow we are going to talk about AI models for infrastructure part 3. So the first part, which is on lecture 6, we are going to talk about the AI models for infrastructure monitoring, that what are the monitoring methods we have, such as classification or any other methods, decision tree. And then we will also talk about the predictive maintenance using these AI techniques. Following that, we will talk about the real-time anomaly detection and fault detection, fault identification for infrastructure monitoring. So we have like three sections of the discussion today. With the start with, we will start with the classification first. So if you have heard about the technique which we use using the AI model, the classification technique is very important. Specifically the classification models, because they are actually being used for infrastructure monitoring, and this is one of the very foundational AI approach that allows us to automatically detect and categorize the damage or risk in engineering structure. So what these models actually do, so this model starts with a set of data and they predict whether a new output belongs to a particular category or class. And this is a very same principle behind many applications you will be familiar with, such as voice recognition or predicting the correct words, or even in the medical image or in the medical field system predicting a diagnosis. So this is actually being used quite a lot. If you will think about the infrastructure monitoring, or in infrastructure we applied a similar kind of principle but to the sensor data. So what we do is that for sensor data which we collect from bridge, building, pipeline or any other kind of structures or assets, we do use it. So given a certain set of features such as strain readings, vibration patterns, temperature or other sensor measurement, we do use this kind of classification methods, we do use this kind of classification models which can predict whether the part of the structure is damaged or is healthy. And how this actually works in the infrastructure monitoring, in its most basic form, we generally use it. So the model outputs are discrete class level, and if you try to think about in our context, you could see that it might simply label a section of infrastructure as damaged or section of infrastructure as healthy or non-damaged. So however, if you think about this classification model, the approach we will try to use for this is to work on a larger scale. So we need to quantize the damage states for this kind of model, and that means that dividing the entire structure into small pieces or smaller label substructures, and each substructure is treated like a data point, and the model then classifies each one separately. This is actually help us or the algorithm to localize the damage more precisely. So we mainly or generally use it also for the localized damage, but also it means that we use too few levels, right? We risk losing details sometimes as well. But there are a lot of advantages for this classification model, and one of the strengths of this classification algorithm or model is that they can provide a probability or confidence factor with each prediction. Okay. So instead of a simple way of yes or no, the model might say that there is a 85% confidence that the area is damaged, or 15% confidence that the area is not damaged or in a healthy situation. So furthermore, if you will try to look into this classification model, it can be extended beyond the simple binary outputs to diagnose the type of damage. And now if you will try to look into the another kind of model except the classification model, so there is another important core model in the AI technique, and that's been called as a regression model. So to regression model is one of the another core AI technique, as I said, and they are applied to the infrastructure monitoring quite a lot. So while when we talk about the classification models, they are about predicting the categories, whereas regression model is predict the continuous values, and which is actually very important and equally very important when we talk about the infrastructure monitoring. And what this regression model generally do, so this technique actually predicts a numerical value because it's a very continuous variable rather than a category. So the previous one was more into the category, whereas this one is going to predict one exact numerical value. So if you can think of like an estimation of price of a house that is based on the size, location, feature and many other aspects, or predicting the amount of the rainfall based on the temperature, the place, the humidity, or the atmospheric pressure. So in the context of this kind of infrastructure monitoring, this kind of regression model is very valuable for tasks where the output is not just damaged or healthy, but you want some kind of measurable quantity. Okay. For example, you might see that when we use this kind of regression model, we try to predict the exact location, okay, or a fault in a Cartesian coordinate. So these kind of things, especially when you try or essentially pinpointing where the structure, the damage is happening, where the crack is happening, that means very detailed information we want to know, right? So this makes this regression particularly very useful if you think about planning the repairs or prioritizing the invention, where the repair should happen and how important that is over the period of time. So instead of simply alerting the engineer that okay fine there is some damage, it's also saying the severity of the damage, the location of the damage. So it's in that way regression models are often non-linear in practice compared to the other one. So meaning the relationship between the inputs and outputs is not always a straight line, right? This is where the machine learning actually uses some kind of neural network. And they can actually handle complex problems, they can handle non-linear relationship between many variables at one point of time. So by doing this kind of, or by using this kind of models, they can actually help us or provide us a much richer, more detailed picture of the structural health than the classification model. So they can complement the classification also. So you can use it together to understand, okay fine, there is some damage, and now by using the regression model, you understand where the damage is happening and how intense the damage is. And then there is another important one, which is the time series model. So in the time series model, you can see that there are very powerful tools compared to the regression and classification. It is also one of the powerful tools. And in the machine learning or even the AI, we kind of use this quite a lot because of, especially in the infrastructure monitoring. So unlike classification or regression, which deals with the individual data points or very static kind of features, what time series does is that time series model actually helps you to analyze how the data changes over the period of time to make some kind of prediction about the future. And that's where it is different compared to the regression or classification. So time series actually forecasting tries to model the historical data points to predict the future value, and this is very important or crucial for infrastructure monitoring because many structural phenomena such as vibration or load variation or temperature fluctuation that happens over the period of time, and that some may follow some kind of pattern. So that's the reason that time series models or time series are very important. And there are also certain changes, limitations of this time series model because the time series forecasting comes with a very unique challenges compared to other model types. If you think about the seasonality or holiday effect, so infrastructure loads and stresses may follow daily, weekly or session or seasonal cycles. It may also can have some data sparsity. It can also have some kind of changing trends as well. Okay. So time series models are not limited to forecasting future values. They also support tasks as anomaly detection. That means you can identify the unusual events like sudden spikes or sudden changes in strain or vibration. You can also calculate some kind of uncertainty quantification. That means you can estimate how confident we are in reach for the forecast. And then there are another importance, which is the causal interference. So you can determine whether one event actually cause another over the time. So basically you can see that time series models are very versatile process, and these are very invaluable tool, especially when you are thinking about critical infrastructure monitoring. And now if you will try to kind of understand or summarize how this time series model add the dimensions of the time to our analysis to help us not only to understand the current structural health but also anticipate the future behavior over the period of the time. And then they can also spot the anomalies, they can also manage the risk proactively. So there are significant portion of the predictive maintenance also relies on the time series data. They are being generated through the industrial equipment. And then this is because of the equipment fails, and sometimes often the process because of the some kind of small irregularities in operational period. So the process of this kind of time series model, they generally begins with the feature extraction from the raw time data series also. This might include simple statistical measurements such as mean or variance calculation, or more domain specific calculation or domain specific indicators like vibration frequencies, or extracting these features which create a reduced representation of the data. For instance, if you can think about the Fourier transformation or wavelength transformation, they are widely used for this kind of cases, and they are being used quite a lot to move from the time domain to the frequency domain, right? And these techniques help us to understand or pull out any hidden pattern from the vibration data. And they also help us to enable any early detection problem or any early issues in the structure, such as maybe some kind of imbalances, some kind of misalignment in the rotatory machine, if you can think about that. So once these features are extracted, the machine learning model can actually help us to predict whether there are some kind of potential failure or whether we do need any kind of scheduled maintenance more accurately. So beyond the classical feature engineering, we now also have the deep learning approach as well. So techniques like recurrent neural network, which is been called as an RNN. There are also another one which is been called as a short-term memory network, which is been called as an LSTM. They are also important compared to the time series model, regression, and the other one. And they are very, very particularly powerful because they capture very temporal dependencies in the time series data, which improves the prediction very, very accurately. And then there is another important one, so which is the decision tree. So decision tree is also commonly used algorithm in the, especially when we talk about the infrastructure monitoring. And decision tree have revolutionized our ability to find the patterns. They also help us feature in the large scale database. They are very popular for both discrimination as well as predictive modeling because of their easy to understand structure. They are very easily, you can understand the structure quite easily. So this is one of the particular case here. And the decision tree is simply a powerful representation of finite number of classes. So it consists of mainly three parts. One is the node, another one is the age, and then another one is the leaves. So it has main three parts which is being made with the decision tree. Node generally represents the name or the attributes of the object, whereas the age represents the possible value of the decision, and leaves present the different cases or outcomes. So to classify an object, we simply follow a path from root down to the tree, and then choosing the edges that corresponding to its value until we reach the leaf where we get the predicted results. Okay. And this kind of models are built by analyzing a training data set. So we need to train the data where the class levels are known. Once the training data is done, these trees can actually classify previously unseen example as well. So the accuracy of these predictions are really good. However, they depend on the quality of the training data. The way you train your model, that is also very, very important, especially in the case of decision trees. In the field of data mining, we do quite use it a lot because these models are widely used to develop classification systems that can handle multiple covariants at a time or can create predictive algorithm for a targeted variable. So in a short, you can understand that this kind of models actually can offer very powerful, interpretable as well as scalable approach to predictive modeling. And then if you will try to see how they are being trained and how they are being actually validated. So when you have a very sufficiently large data sets, we can split into two parts, right? One as a training data set and one as a validation data sets, right? And the training data set is used to build a decision model, and while the validation data set is used to fine tune the tree, right? Two ways we can do that. One is training the data set and another one is the validation. So these two division we do. Training one we use to build the model, and the validation one we use to fine tune the model, right? Basically converge the model and get a better performance. The training data set is used, as I said, that they are kind of used and then the validation is used to fine tune also, so that we don't get any kind of overfits and we can achieve the best possible model for our data. That will help us to get a very great prediction, right? So now if you will try to look into the decision tree, you can see that there is a top node, as I said, which is being called as a root node. If you will try to look into this figure here, this figure depicts a very simple kind of decision tree, and here we are trying to show that, you know, if you can get an example of the Titanic passenger data set. At the very top, the first one, that's is made of gender, that means male and female, and then for males the next decision considers the age, right? For younger the passenger, another split considers the number of siblings or spouses on board, right? So each of this leaf or the leaf node, they shows a percentage, and this represents the proportion of the data points in each of these categories. Okay. For example, according to this model, if you can see that there was a 61% male passengers over the age of 9.5 did not survive. You can see that, right? Whereas 35% of the male survived. So sorry, female survived, right? So this example actually illustrates how decision trees classify data step by step here, following rules at each node until we are reaching to a final classification or final decision at the leaf, okay, which is this one. And it's a very simple yet powerful way to visualize and understand how the predictions are made. And now with the continuing the decision tree, then there are two main types in the data mining. The first one is, as I said, the classification tree, and the second one is the regression tree. Okay. So the classification tree, these are used mainly to predict the outcome, determines the class to which the data belongs. For example, if you think about the bank, they often use the classification tree to decide whether a loan applicant falls into the safe or the risk category. That's being counted as a classification tree. Whereas the second type is the regression tree. So what happens in the regression tree is that this kind of models, we generally use it when the predicted outcome is a real number rather than a class. Okay. So a typical example would be estimating the population of the state or predicting a continuous variable like house prices and those things. And there are several well-known statistical algorithms for building this kind of decision trees. Among them, one of the very famous one is the CART, one is the C45, then CHAPE and QUEST. So now if you will try to look into the all of these models, so the CART or the CART model, we do use it for the short classification and regression tree. So both and they build both classification as well as regression trees by splitting the data based on the most informative results they are having or most informative features they are having. And it works with both nominal cases, it also both work with the continuous data, and is known for its very efficient processing speed. But you have to always remember that we do use it for the short trees, not for the large one. Okay. Whereas if you try to look into the C4.5, they are the algorithm which is widely used to generate decision trees for classification. So CART can be used for classification and the regression for the short cases, or whereas the C45 is generally being used only for the classification. Okay. So one of its very important or key strength is that the tree pruning process. That means it can produce small trees with a very simple rules. And this leads to more intuitive and very easy to interpretable models. So you can interpret the models very easily. So if you will try to look into this, you can see that these trees are not only versatile, but they can also come with certain algorithms. The another one is the chain one and then the quest one. So this model, they stand with the chi-squared automatic interaction detection. In short, we call it as a CHAD. Full form is that chi-squared automatic interaction detection. So this is an algorithm we generally use to analyze the relationship tree models, and it creates a tree diagram that can highlight the relationship between the speed variable and their related phases or the factors. This kind of models we generally use for regulating and understanding the impact of different variable or outcome. For example, you can think about you are trying to evaluate individual defects or try to classify them effectively. So those are the places we kind of use this kind of variable when we are dealing with the data sets where the relationship between the variable is very complex and needs some kind of statistical validation. That's the time when we do use it. Whereas the quest one is another algorithm that we generally use for the very quick, unbiased and very efficient ways. Okay. So if you try to think about this quest model, they are very efficient statistical tree, and they are being designed for classifying tree structures, and it is built on the idea that the target is variable is continuous. So for the continuous target variable, we generally do use this one. And one of the major strengths of the quest models are they are very computationally efficient. So computational speed is very good. It's very faster than many other methods. And additionally, this kind of models help us to reduce the bias in splits. They often challenge the traditional decision tree algorithm. So they are very quick, unbiased and efficient statistical method. So now if you will try to look into all of these algorithms, you can see that the quiz algorithm works well in a multiple category variables, but is primarily limited to the processing of the binary data. So that's their one of the disadvantage, or you could say limitation. Especially it is very effective, this kind of quiz algorithm, when you need a very fast unbiased quantification or fast and unbiased classification, which makes a very good alternative to more traditional algorithm like this first two, okay, which is the CART and the C45. And now this is a very nice diagram where you could see that how the decision tree methods are being applied for different classification and prediction. And so I have tried to divide into some major decision trees, and we will try to see that where does it work. So now starting with measure used to select, let's try to select the input variables here. So now if you will look into the CART, you will see that the CART one, they generally uses the Gini box or the towing criteria. Whereas if you will look into the C4.5, they uses the entropy or the information. That means that can measure how much the feature contributes to reducing the uncertainty. And similar way, if you will try to look into the dependent variable, you can see that whether they are categorical and continuous. So these are the details, generally the decision tree this one is giving. Now there is another important one, which is the SVM, and SVM is basically been called as a support vector machines. So support vector machine is also another kind of machine learning model. They are also based on statistical learning theory. It is very essentially supervised algorithm. It's not unsupervised. That means designing of this kind of model is the supervised learning algorithm, and their main goal is to making a very accurate prediction. So what makes this SVMs unique is that it learns from the existing training data and then generates the decision rules, and that is going to classify or predict the unseen data. So at the heart of this SSVM is the principle of the structural risk mitigation, so basically or minimization, and it's also been called as an SRM. So this principle generally try to understand or object is that to balance the model complex and accuracy, which allows the SVM to achieve very small errors. And then there are certain advantages also of this SVM. So one of the very good advantages is their simplicity of tuning. So SVM only has two parameters to choose from, the upper bound and the lower bound. That means it's very relatively straightforward or very simple. And the another one is their optimal and global solution. So unlike some other methods, this kind of models finds a very unique optimal as well as global solution for the problem. That means it can have some optimal solution. And then the another advantage of this one is that their strong generalization performance. So due to the SRM approach, that means due to the structural risk minimization approach, these SVM models tend to generalize well to new, unseen as well as not known data, and that's the reason they are making them very highly reliable. So overall, if you will try to look into the support vector machine algorithm, you can see that they actually contribute a very strong theoretical background with practical benefits. They also making it one of the most widely used and effective algorithm when we talk about the classification, regression, and many other predictive tasks. Now continuing with this support vector machines, you can let's try to see that how they create the decision boundaries. Okay. So the goal of this SVM is mainly to create a decision boundaries, as I was saying, between the two classes. This boundary has been called as an hyperlane, and it positions in such a way that it's far as possible from the closest data point of each of their class. And these closest data points are known as a support vector. Okay, and they are very key to defining the hyperplane. So now if you will try to look into these decision planes, you can see that they are the heart of this SVM model, and they indicate where one class ends and where the other class begins. And by using the linear models to implement the nonlinear class boundaries, using this model, we can actually generate a very high level of hyperplane through the nonlinear mapping. And if you will look into this hyperplane in some kind of dimension, you can see that they are very much flat subspace, and then they are very regularly used. And then if you will try to define it mathematically in two dimensions, it can be defined as beta 0 plus beta 1 x1 plus beta 2 x2 equals to 0. When you will try to write down in a plane of p dimension, it can go to beta 0 plus beta 1 x1 plus beta 2 x2 to beta p xp equals to 0. So here with x feature vector, we classify one class having beta so beta 0 plus beta 1 x1 plus beta 2 till the beta p xp is always greater than equals to 0, and then the other class you can find that it is less than equals to 0. So So in simple terms, you can see that the support vector machines, they find the line or plane or hyperplane in higher dimension. So that's actually the best way to separate the data, maximize the margin between the classes, thus improving the prediction accuracy. Now let's try to see this figure, that how it could possibly look like. So on the graph you can see that we have two sets of data points, the blue points and the red points, right? And that represents the two different classes here in the graph, okay? The goal of this support vector machine algorithm is to find the optimal hyperplane, and that is shown as this solid line, this one here, the black solid line, and that is actually separating these two classes as clearly as possible, okay? And what is this dash line here? The dash line is for both of the sides, they represents the margins here, right? These margins define the space between the hyperlane and the nearest data points for each of those classes. And the data points that sit very exactly on the margins are known as this one or this one, which is very close to the margin, are known as the support vector, okay? And they are very critical because they determine the position and the orientation of those hyperplanes. They are very important. So by maximizing the distance between the hyperplane as this black line and support vector, these methods or these models can achieve the largest possible margin, okay? And the maximization of margin is what gives SVM its strong ability to generalize to new data and improve their classification accuracy. And that's how generally this SVM vectors or SVM machines model work, okay? Now if you will try to think about one of the most powerful aspects of the support vector machine, that is the kernel trick. In reality, most the data sets are not linearly separatable, right? We know that we cannot linearly separate most of the real life data sets. That means that a simple straight line or a plane, which is this one, right, cannot actually divide the classes so cleanly, right? I mean, if you think about the real life. So handling this, we project the data into a high dimensional space where it becomes easier to find a separating hyperplane for the support vector classifier, right? So however, working on a higher dimension, that brings the challenges as well. So when you think about the support vector machines, they become harder to interpret, and calculating these high dimensional transformations directly can also be very computationally expensive. And this is where the kernel method comes into the picture, okay? So the kernel method, they allow these SVMs to model high dimensional cases or nonlinear relationship without expressing or without doing any kind of complex calculation, and that's where this kernel methods actually work. And by using these kernel functions, these SVMs can compute the relationship between the data points in the high dimensional space very, very implicitly, okay? And they can also turn into some nonlinear problems to the linear problem as well, and that is the way the transform space works. And how does it actually work out? So if you will look into this kernel trick, instead of transforming each data point, what the kernel trick does, they kind of compute only pairwise comparison between the data observation, right? And that we do use by using the kernel function, and that being defined as k is a function of xi and xj, and this is being called as a kernel function. What is kernel function? So instead of transforming the each data points, what kernel trick does that they compute only the pairwise comparison between the data observation, and that is being done using this kernel function, okay? And this function acts as a modified dot product on the transform feature vector, right? And the result is that we effectively operate a high dimensional space without ever explicitly calculating the coordinates there. So what is the benefit of doing this compared to the previous SVM? So the ultimate benefit of this kind of kernel trick is that it optimizes only the dot product which needed to be fed directly in the decision boundary, right? And that makes it's computationally efficient, so our calculation is not going to be computationally heavy, while we are still able to capture the complex pattern in the data. And that's where this kind of kernel trick does. In simple term, if you want to say that the benefit of this kind of kernel trick, that actually allows this support vector machine algorithms or these SVMs to scale from simple linear separation to the highly complex linear classification. So we can go to highly complex nonlinear classification without using any kind of huge computational burden. That means it becomes computationally efficient even we go for the very complex nonlinear data sets, right? And then comes another important one, which is the random forest. That's also another very powerful and widely used machine learning algorithm. So random forests, or this has also been called as an RFs. So they are also supervised machine learning algorithm, which is being used for both classification tasks, which is also being used both for the regression tasks. And the idea for this RFs are that was popularized in 2001, and they kind of try to draw the inspiration from the randomized tree or Ho's random decision forecast. Okay. So what makes this random trees stand out in their high predictive accuracy? So they do have a very high predictive accuracy. They have been applied successfully in many areas. For instance, predicting the drug responses in cancer cell walls, identifying the DNA binding proteins, and even localizing the cancer to a specific tissues. Beyond biology, this also been used or capable of using the recognizing the speeches, the speech as well as the handwritten digits with a remarkable accuracy. So they are one of the very big advantage is their high predictive accuracy, as we say. And this kind of models is very, very important and essential when we talk about collection of decision trees. Each tree works as a very portion of the data, and their combined result, they can produce a very stronger, more robust prediction. And this can actually help us, or these models will enable the approach of reducing the risk of overfitting compared to the single decision tree. So that's where the benefit also lies. And how this generally works, we start with the dataset mode, which is made of samples and each described by features. Okay. And as we move down each decision tree, the algorithm follows a path of decision points, which applies to ruling of classifying each of those samples. Right. That means we move down to each decision tree, the algorithm follows a path of decision point, and then it applies the rules of classifying each of those samples, right? And at the end of this path, we reach to the leaf node where we try to represent the class of label or prediction. So by combining the output of many trees, this kind of models actually can provide you finally more accurate prediction compared to the other decision trees. And there is another important strength of this particular model is their feature importance analysis. So they can identify which feature contributes the more into the prediction and which feature contributes less in the prediction. That actually makes them especially very, very useful in the high dimensional data sets. So if you will try to look into this RFC, you will see that they combine the simplicity of the decision tree with the power of enabling the learning, resulting in one of the most reliable and versatile algorithms with high predictive efficiency or accuracy in the machine learning models, right? Now if you will try to look into that how they could work behind the scenes, if you will look into this RF models, as I said that they are very, very essentially what they do is the collecting of the tree structured classification, and each of the tree is in the forest is trained on a normal or on a random sample of the data. And how it actually works, let's try to look into this example here. So we start with an input data set A, okay, which is described by several features, and in case in this case what we do is that if you will see that we have taken the features of x1, x2, x3 to x5, and each decision tree is a forest like B or C if you can see in the diagram, and that can evaluate these features and branches of at each decision points, okay, and that could assign each samples to one of the branches depending on its feature value, right? And these branches can terminate at leaf nodes or leaf points, which can represent the class, for instance red or green, whatever it could work. And now if you will see that once all three make their individual classification, so the same sample could be classified differently by different trees, right? That means decision from many trees produces a final prediction, which is being called as a E. E is the final output. So you can see that by using this kind of voting mechanism, we call it, that what it makes this random forest so powerful. So instead of relying on one single tree here, we are trying to relying on forest blends in the multiple perspectives, which increases the accuracy, our prediction. They also help us to reduce the overfits, and they also provide a more reliable prediction compared to the depending on only one tree, right? So let's try to look into this particular case here, okay? Particular figure here. So on the left under section A, we have the input data set in the figure, okay? It contains multiple samples, each described by several features. Here we have taken x1 to x5. Each row represents a sample and each column represents a feature, okay? And now if you will move from input to the B, okay, so B and C. So B and C, we see the two decision trees here, okay, and each decision tree applies to its own set of rules to the data. Fine. For example, in decision tree 1, you can see that the first feed might be based on whether the x5 is greater than 2. Depending on the answer, the sample travels down to the branches to the next tree, such as whether x2 is greater than 1 or x3 is greater than 2, and so on, right? Eventually, the sample reaches to a leaf node which assigns it to a particular class, and then it will show that whether it's green or red. And if you now look into decision 2, decision tree 2, they kind of does the similar things but in a different splitting rules compared to the 1, okay. So now if you will move from B, C to D, D is actually representing the random forest here. So what it does is that it combines the prediction from decision 1 as well as decision 2, okay. And by aggregating their votes, the forest arrives to a very stronger and more reliable prediction, right. So finally we comes into from D2 we comes into point E, okay. And what E does is here, E is the output here. So basically, which is the final predicted class. After combining all the votes from the decision tree, this diagram highlights the code strength of the random forest. By using multiple decision tree and voting, we get a model that's more accurate, less likely to overfit compared to the single decision tree. So this is the whole process of how random forest works. First, we input the parameters, right? Then we take two different decision trees, and both of them have different way of calculating whether it comes for red or green, and then we take the random forest which combine the decision of both decision tree and decision tree 2, and then it finally goes to point E where it kind of say whether it's green or red. So this is the final output. Clear to everybody? So now you will see that if you will try to look into why they are so powerful, the random forest, and how they address some of the weakness of a single decision tree, you can see that there are a lot of advantages, and we will try to look into the key advantages it could possibly bring to us. So although these decision trees are very easy to interpret, they often perform poorly on their own, especially when it comes to predictive the accuracy. Now if you will see this kind of random forests or RFS, you can see that they improve the performances by combining many decision trees as we saw last diagram and aggregating their votes, right. This approach actually leverages the randomization at two levels, right. First, at each tree the algorithm select the best feature from the random subset, right, of all the available features are available in the data. And second is that because of this random selection, each tree focuses on the different aspects of the data. So it means that your tree 1 and tree 2 will definitely not gonna do the similar feature, not gonna do the same way, right? Your tree 1 and tree 2 will always focus on different aspects of the data. And that's where the beauty lies of this random forest, right? And that can create diversity among the trees. So your tree 1 and tree 2 will select different aspects of the data. And the diversity actually helps this kind of model to capture more complex feature pattern which we cannot do maybe with one single tree. Right? That's where the beauty lies, and that actually improve your predictive accuracy. That actually give you or reduce the overfitting some way, and compared to, as I said, one single decision tree. So you can see, in fact, in it's been mathematically also you can see that there are number of tree increases, the error rate converges to a stable point. So now if you, as I said, that there are a lot of advantages of this kind of models, and one of the key advantages of this kind of tree over the available one, maybe you can compare it with the other boast, you can look it into later. So, but if you look into this kind of model, you can see that they are specially sturdy against the noise and overfitting, these models, and they often achieve similar or better accuracy while being faster and simpler to implement. So random forests also provide a very useful internal estimation, like feature important measures, or which help us to understand which feature drive predictions. So on the other hand, if you can also see that the overfitting can still occur in models that are too complex or trained without enough generalization. So random forests are designed to generalize well to unseen data, which is critical for real world use, right? So if overfitting occurs, classifiers tend to perform very poorly on new data. There can be some higher error rates for out of back prediction. Then you can see that sometimes random forests can also have some overfitting issue, right? So basically, if you will try to look into this random forest model as a whole, you can see that they try to combine the simplest simplicity of the decision tree, right, with the power of randomizing or with the power of randomization as well as aggregation, and that actually help us, or that actually produce a very robust model which can resist to overfitting, and they can also highly reliable when we talk about the prediction task, right? And that's where the random forest models work best compared to the one single prediction tree. Okay. So now let's try to move into the another important factor, which is the predictive maintenance in infrastructure. So what do we mean by predictive maintenance of the infrastructure? So basically predictive maintenance means usually real-time equipment monitoring and data analytics to proactively improve how the maintenance services are being performed. Okay. So rather than waiting for some time to break down, predictive maintenance allows us to anticipate problems before they can occur in the infrastructure. And in practice, this involves analyzing the condition of the equipment using data and machine learning, so that technicians can be noted about the potential issue very, very early. And that can make the maintenance not only reactive, that can also make the maintenance very, very proactive, and that saves the time, and that also saves the cost. Okay. So now if you will try to look into the main aim of this predictive maintenance, you will see that they try to improve the way maintenance services are being delivered, okay, and with the help of real-time data collected from the sensors and diagnostic tools inside the equipment, you can see that this kind of methods, predictive maintenance software, they can determine when and why the failure might occur, okay. And it is essentially transforms the maintenance from a schedule or emergency activity into the very strategic and data-driven process. Okay. For example, you can imagine about the temperature sensor, that detecting a component is running hotter than the normal. This information actually could trigger immediately to corrective maintenance that of the issue, right? Or whether there is a minor one or it's a major one, and that actually help us to or allow the repair to be planned for the next scheduled maintenance period, right? So ultimately you can see that the predictive maintenance that increases the safety, they also prevents the unexpected failures and help to avoid the high cost which is associated with the equipment breakdown. So by applying these methods in infrastructure as an engineer, we can actually improve the reliability, we can extend the lifespan of the structure, infrastructure, equipment and optimize the maintenance resources over the period of the time, right? Now if you will try to look into how this kind of predictive maintenance is differed from the preventive maintenance and why it is so important when we talk about the valuable infrastructure. So generally if you talk about the preventive maintenance relies on the expected life statistics, right, to plan regular maintenance intervals. For example, a part might be served or serviced like every 6 months or every 1 year, depending on its actual condition. Okay. Whereas if you think about the predictive maintenance, they actually uses the real-time data and they actually kind of actual condition of the equipment to anticipate the performance before they occur. So that's how, like if you think about a car, so every few months you go and then you go to the mechanic and try to understand that whether there is some issues and then you rectify the issue, right? That is being called as a preventing maintenance. But what if that there are already some internal issues, and which you are not able to understand it. And that's where comes the predictive maintenance compared to the preventive maintenance. So in the predictive maintenance, what you do is that you monitor it over the period of the time, you get the actual condition of the equipment, and if you need to kind of go to the mechanic or if you kind of need to take care of the machine, you kind of do it before the maintenance period. And for that, you can kind of save a lot of cost or human safety, reliable maintenance. Many of the things you can actually do by using the predictive maintenance instead of the preventive maintenance. Okay. So if you will try to look into this preventive maintenance also, they kind of stand out because it leverages the IoT sensors, which we are quite concerned about, and continuous data streams. And this real-time data, they allows the organization to detect the potential problems and the cause failure before they happen. So beyond that also, this predictive maintenance can actually automate the task. They can also make decisions based on the large continuously gathered data sets, and something preventing maintenance cannot achieve throughout the time. Okay. So as I said that the advantage of the predictive maintenance is very, very clear when problem can be predicted and failure anticipated rather than discovering during the routine inspection period. So that is actually, as I said, that saves time, that saves cost, that also saves the human life, and sometimes many other aspects are actually associated with this. And it also, as I said, it also saves some unplanned downtime, so or it improves the asset of the life, ensures the maintenance. So there are many things which have been associated. So basically predictive maintenance, they shifts the maintenance from calendar based routine to the very smart data driven proactive process that can deliver a far greater efficiency, that can deliver a far greater reliability compared to the preventive maintenance. Okay. As I said that there are a lot of importance of this kind of predictive maintenance. The key benefit, as I said, is to or being able to increase the operational efficiency and minimize the downtime. And this can be achieved by combining a flexible maintenance schedule with responsive real-time equipment. So predictive maintenance actually analytics offer a variety of valuable benefits which I have tried to highlight here. The first one is the visibility. That means visibility into an equipment problem is likely to occur, allowing technicians to act early rather than the continuous process can be done rather than on a specific period of time. And then another one is the asset management information that actually helps to prolong the life of the equipment and avoid the unnecessary replacement. Then another important one is the equipment status update, then flexibility, and then inside of improved inventory control. The last one is the verification. So basically verification or the verifying that the maintenance and the repair have been done correctly. Okay. And that actually add on to the confidence of the process. So altogether, if you will try to look into their advantages of this predictive maintenance compared to the preservative one, you can see that this predictive maintenance transforms the way we manage our system, transforms the way we manage our infrastructure. That not only improve the reliability, they also help the cost, extending the equipment, and those kind of things, right? So now let's try to look into the machine learning models that are transforming the predictive maintenance to anticipate failures and maintenance needs. So artificial intelligence is becoming, as I said, a very powerful driver in the predictive maintenance across a wide range of industry, from manufacturing and fleet management to energy to mining to recycling. So sophisticated machine learning models, they allow us to monitor the equipment condition, they kind of help us to detect the anomaly, they kind of help us to predict the failure, the outages, the optimize the energy usage, as well as they also help us even recommend the corrective actions we should possibly take if there are any kind of anomalies or any other factors. Now if you will try to focus on the key applications, you can see the first one is the outrage prevention. So by gathering the large amount of historical and real-time contextual data from the connected asset, by using the AI-powered or AI-inspired predictive maintenance, that can help us to reduce the cost outrages. Okay, this algorithm actually analyze the incoming data instantly, and they can alert us about the potential issues, such as some overheated machines or some irregular voltage levels. So that's way before we can actually understand it, and then way before a breakdown can actually happen. For example, as I said, a major aluminium producer uses the AI tool, right, to monitor the robots or the smelting plant equipment. So now workers can actually receive the maintenance alerts at least 2 weeks in advance to understand that whether there are some kind of issues or not. Whereas the another one is the conditional monitoring. So what we does in conditional monitoring is that these machine learning models, they also revolutionize how manufacturing or how manufacturers monitor the equipment condition, right? So by using this artificial intelligence model, we can recognize both normal as well as abnormal operational patterns far more accurately than the older techniques, right? And this system actually analyze the real-time data on equipment health or identify the relevant patterns, or we can predict the failures quite early. So crucially, you can see that this kind of models actually help to determine the maintenance priority based on the life condition rather than a rigid schedule or the maintenance schedule. In essence, you will see that this artificial intelligence driven predictive maintenance, they allow us to be proactive. They prevent the failures before they can possibly happen, and they also keep the operations running very smoothly. Now the another important one is the anomaly detection. So traditionally anomaly detection, they relied on rules based system with with hardcore threshold. For example, if you think about the machine's vibration, that might be compared to an ISO standard, right? Or any excess would trigger a report of maintenance. So while effective in simple scenarios, you can think about this kind of approach actually struggle with the today's complex machine that can produce enormous volumes of data, not just in vibration but also in temperature, pressure, heat, or many more cases, right? So older the system cannot easily interpret such varied information. So by using this artificial intelligence techniques, we can actually change the picture quite completely. So AI systems don't just collect and analyze the data, they will learn from it as well. Okay. So by adapting over the time, by using the AI tools, we can identify even there is any faintest amount of performance deviation, right? And that can catch the problems at their earliest stage. So this can actually help us as an engineer or the company to take any proactive action before any kind of disruption happens in the infrastructure. Then another one, except the anomaly detection, another one comes, which is the failure prediction. So artificial intelligence also looks into the historical performance, as we are seeing. This can combine with the real-time sensor data to build a predictive model of equipment. So we can, by using these AI tools, we can actually combine the real-time sensor data with the historical performance data, right? And as more the data flows in, the model adapts and predicts failure with increasing the accuracy, right? So the more data will flow in, the model will adapt more, and then that will predict the failure with more accurate cases, right? So using the deep learning methods also, by using the AI tools, we can discover the patterns that older methods, including human observation, often misses. So by using this AI tool, what we can do with the human observation, sometimes or most of the times is difficult to do. For example, if you think about a multinational package delivery company, right? They use the AI to monitor over the 30 types of machine at its sorting facilities, or by spotting the gearbox failure or any kind of damage or other issues quite early, and that actually helps the company to save millions of dollars very early, which can prevent the downtime, right? We can also prevent the repair. So now the another important one of this machine learning models is that planned maintenance, prioritizing, and scheduling. So AI also improve traditional maintenance schedule by pinpointing the problem very early, by identifying the priorities, and by reshuffling the schedules in real time, right? So instead of only reacting to the current issues or relying on the past data, this artificially driven method this artificially driven predictive maintenance can project what's likely to happen if conditions remain unchanged. And that insight empowers companies to take proactive steps, reduce the downtime, and improve the outcome. And the next one is the energy optimization. So as machine ages, they tend to become less efficient, using more energy to produce at the same output. And this efficiency can be costly. For instance, if you think about a compressed air system in some of this US based, an estimated cost can be 3.2 billion annually, even sometimes more than that. So by using this AI based predictive maintenance, we can, or the company can actually find flaws very early, and that can schedule repair to prevent very unnecessarily energy losses, right? And that's a quite huge kind of economic saving as well. And then another one is the computer vision. So computer vision allows the AI to see and analyze the machine condition. Like manufacturers or engineers can train the AI system to process the video footage or to detect the subtle anomalies in there that might otherwise be missed by any human. Such a sign of wear and tear, like misalignment of some kind of parts or even some kind of damaged packaging. So those kind of things can actually be used by using this AI predictive maintenance. And these visual insights actually complement the other data, like helping the companies to identify the root causes. And that can actually help also to take the most effective corrective actions, right? So together you can see this kind of innovations actually can help on the smart scheduling, they can help on energy optimization, they can help on computer vision capabilities. They represent actually a transformative leap into the predictive maintenance by using this AI model based predictive maintenance, and they can actually operate very efficiently, sustainably, and these models are way too reliable compared to the human based predictive maintenance. Okay. Now if you will try to look into some of the real world example of predictive maintenance in action, and these examples show that how some of the largest manufacturers, they are using this AI based predictive maintenance to enhance the maintenance, to improve their uptime. So the first one is the global automaker. So they kind of employ the AI power computer vision and deep learning to inspect and maintain its building robots. So by analyzing the images and videos, the AI system can spot the defects that might otherwise can be missed. Okay, and if then recommend then optimal settings and alerts to the worker can be set out when maintenance or replacement is required, and the impact has been quite impressive. So the what company then reports the robot inspection time has been reduced to 70%, and that's a huge one, while welding quality has improved 10%. So this is not only boost the efficiency, but it also improves the product quality and worker safety of the company, right? And another very famous one is the GE Aviation. So GE Aviation also uses the AI to predict the maintenance and needs to of its jet engine used by airline worldwide. So it's a very famous aerospace company you have heard about. So more than 44,000 engines are equipped with embedded sensors that are continuously feed the performance data back to the GE's Monitoring Engineer System Center, which is in Sydney, USA, and also in Shanghai, China. So by combining this data, with physical engine models and environmental factors, what this company can do is that they can actually predict the maintenance issues before they can occur. And this proactive approach actually reduced the maintenance cost in a very high range. They boosted the engine's reliability also, and they also even enhanced the safety for the airline passengers. So you can understand this is also kind of not only saving your cost, your some way, the reliable structures. This is also saving a human safety when we are talking more into the cases like buildings, bridge, aircraft. So that's where the human life is a huge way, some way associated as well. So both of this kind of, and then there are other companies like Rolls-Royce and Airbus, and there are many other companies like BAE System, which are mainly kind of quite associated with making these aircraft parts or engines. They are quietly use this kind of AI-based infrastructure or AI-based predictive maintenance quite a lot compared to the regular scheduled maintenance. And you can see that by using this kind of methods, they have reduced their maintenance cost quite high, and then they have also boosted their performances and then satisfaction of the passengers as well. So you can see both of these examples show that how predictive maintenance by AI is transforming the industries. And not only here we have talked about two type of cases of industry. One is the robot based and one is the aviation industry, because it's been used quite a lot in these cases. But it moved the companies from the reactive stance, that means it's fixing things before they fail, okay, but to a proactive stance where the maintenance is planned and downtime has been also reduced by using this AI based predictive maintenance, and the cost has been also cut dramatically, right? So it's not just about the technology, it's about creating safer, more efficient and more sustainable operations, right? So now if you think about this AI-based methods and if you think about more infrastructure cases, so can you give like two examples where we can use it into the civil infrastructure? Any companies you have heard about or you think that it could possibly be used about in the civil infrastructure? Let's talk about some civil application.
Bending the metamaterials by manually at a particular angle, that will be very difficult for the doing at a such small scale. But AI-based computers or robots.
So we are talking about the predictive maintenance here, not using the AI for the advanced manufacturing, right? Anyone that any kind of civil infrastructure or infrastructure cases where you think that we can use this AI-based predictive maintenance to make the similar way that it reduce the cost or other perspective.
We can use computer vision for damage detection of buildings or bridges using drones or UAV for marking these areas or emergency areas.
Yeah, that we can do that, but how over the period of time we can do that compared to the preventive analysis? I mean, definitely we do something like that compared to the preventing to understand whether there is some crack, and we do this kind of predictive analysis. That's a very good example. Do you know about any companies which they kind of use it quite a lot? I mean, most of the the consultancies or civil companies, they do use about it. But do you know about any companies which they kind of use it? Any industry? That's a very kind of generalized and very common example for the breach or for any kind of structures. We do detect the or Even for the aircraft structures also, fatigue is a very issue there. And you can, if you will look into the history, you will see that most of the accidents and those things always happen due to the metal and those cases. That's the reason we kind of do analyze, or do detect the predictive analyze of the damage, of the crack, of the breach, building, wherever we cannot go using the drone or any kind of sensor based. And that's a very good example of using this AI based predictive analysis. But what are the other one which you can think that out of the moon that which could possibly be used using this method?
Structural health content you can use it, but like in which proof the damage has been there, which can
That is very same with the previous one, na? Just now we said something else you say.
Can be used in construction management also. To track the worker behavior, the everything.
Yeah, whether the materials are being using properly, whether the things are being built properly. Yeah, that's definitely a very good example of understanding that because when the finally the structure is being made, then you can understand the performance by looking through that predictive analysis, that whether the whole process has been done properly or not. Yeah, that's also a very good example. Anybody else? Anything in your mind?
In railway infrastructure,
Yes.
there also
How we can use it then?
to prevent the collision between trains, right?
Sorry, I cannot hear you. Sorry.
Collision between two trains, like when they are coming for.
Yeah. How we can use the AI based predictive analysis to kind of avoid the accidents?
Maybe some kind of real time image capturing kind of sensors.
So basically what AI predictive analysis is that it is going to monitor the sensor data throughout, or any kind of data throughout a life period of time, and the history also. That means we are taking the history of the data as well as the current data, we combining this together, and then we see that how we can make the performance better, or our infrastructure how they could perform better. So if you think about this railways, the railway infrastructure, so how we can prevent this accident by using the AI predictive analysis?
in railway tracks, if you deploy the sensors and using some sonic technology, if it can detect if there are multiple trains on that track, then I think it will be more effective than using this image, because that's by that you can detect the other train that is on the same
Does
track.
it come under predictive analysis?
Actually, if we connect it with a control room, where these sensors will in real time will transfer the data, and if there is some signal fault or something like that, it can from the control room, if there is some automated mechanism in the engine, so it can automatically shut down the engine or something like that. Like it will prevent from head-on collision way before it will occur.
Yeah, I think that's some way like real-time monitoring we are talking about, right? And then giving us an immediate or live monitoring using, and then giving us an immediate signal that there's something wrong.
Another thing is in bridges like corrosion, that can be monitored using CNN, and it will predict that how
That we have already said in the first one. Say something else. Anybody else? I want now someone else to answer. This is too difficult to think about. There are so many ways we can do the infrastructure monitoring. You can think about the railway tracks, right? If you will have kind of keep monitoring the performance of that, then because we always kind of do it on a yearly basis, or after 2 years we do kind of monitor those railway tracks, right? But if we do have kind of immediate, or the always live monitoring of that by using some kind of sensors or way, we can always track those things as well. And then similar way that there are other cases as well. So give me one other example.
And for dockyard and jetties, if we have to increase the load carrying capacity of the crane, then we can use cycle for the FEM analysis and predict the current health of the jetties.
That is like making your structure better, or some way like improving the structures.
It may come under predictive analysis of
Yeah, over the period of the time, if you want to increase the load and then you can, you want the structure to kind of perform better, or there should not be any kind of accident or something, definitely it's another good example. So I will say that please go back and try to think about it, how you can use any of these models. So we have talked about total several cases, that outage prevention, conditional monitoring, anomaly detection, and then failure prediction, maintenance, energy optimization, and computer vision, right? So think about all of these particular 7 approaches, and you will see that definitely all of them are some way connected. It's not always like individually performing parameters. So you can think about how you can use one of this or maybe 2 of these together in some certain cases. And it does not matter if you are thinking about any civil infrastructure. You may also think about some other cases also. If you can, like, depends on what is your expertise is. So it can be used in any kind of infrastructure, starting from civil to mechanical to aerospace to any kind of to maritime to any kind of infrastructure. So think about it and try to think how you could possibly use that. Similar way, I think because before we go tomorrow to the tutorial, I think this is very, very important for you to understand the whole process. The kind of decision trees we have discussed today, regression, the other kind of reinforcement. So let me just go back to the, random forest, support vector machine, and then we have talked about the decision trees, like what is the difference between the one decision tree and then what is the difference between the random forestry, right? That's very, very important for you to understand. And if you are comfortable, because I think yesterday we took quite a lot of time to kind of write down the codes. So I would suggest that try to write down if you are comfortable, and tomorrow we will have less time. We will solve like 2-3 problems depending on the time we are taking, okay? And one more thing is that I have received like 5 submissions. So if you have done it, or if you, whatever you could do, if you have problem to solve yesterday's tutorial also, please reach back to me, and I would expect that let's try to submit it by this Sunday. Okay? So before we kind of go towards the end, let's try to see some of the quizzes to kind of understand where we stand. So which of the following is a regression task in structural health monitoring? Predicting the probability of the corrosion occurrence, or predicting the exact crack length in millimeters, or predicting which beam is damaged? Which one? B? And which statement describes the random forest compared to a single decision tree? Random forest uses the one tree and overfits easily. Random forest combines many trees to improve the accuracy and reduce the overfitting. And random forest is only for the regression task. Which one is the correct answer? What does random forest does? Which one is the correct answer? Does it actually use one tree and overfits only? No. Does it actually combine many trees to improve the accuracy and reduce overfitting? Does it actually only be used for the regression task? No. So B is the correct answer. And which of the following best describe the predictive maintenance? Maintenance at fixed interval regardless of the condition. Using real data time and AI models to anticipate and prevent equipment failure. And maintenance only after the complete failure. No. B is the correct answer. Clear to everybody? Okay. So now I think we will end the lecture today, and these are the, as I said, these are the 4 references which we have used mostly in today's class, and I think you should be having the videos with you. But yeah, I think if you want to follow the lectures, or if you want to understand where most of the things are being taken, so this all been actually kind of taken from these 4 references, and if you are interested to get into more details, please go through these references and try to see more details about it, right? So okay, I think thank you everybody, and do you have any further questions today? Anybody has anything to ask? If not, then okay, thank you everybody, and I will see you all today at the second half. पाएंगे क्या क्लास से पहले? नहीं मेरा पता भी करना, कल हो पाएगा ना? कल क्लास के 10:30 बजे है। वहाँ से हो पाएगा क्या? कर सकते हैं तो वहाँ the good thing is that because there are like yeah, I think this looks good, right? But maybe you yeah, I think for you also you get okay. So no, this is correct. This is okay. This is also okay. I think you just